In this video, we will learn how to add and subtract vectors, both algebraically and graphically. Now, when I say graphically, we're going to be using two different methods, the triangle method and the parallelogram method. This is going to be very straightforward. We have vector u and we have vector v. If we want to add them algebraically, this is what we do in component form. So vector u, I have -1, 3, and then I'm adding, and vector v, I have this 2, 4. So guess what? I'm just going to add the x components, the horizontal components, and I'm going to add the vertical components. So that's going to be 1, 7. So that is the sum. All right, this is vector u plus v. Now, let's look at that graphically. So vector u was the vector -1, 3. I'm going to start off vector u from the origin. I really could start anywhere. You don't have to put a vector at the origin, but I'll start at the origin because why not? So if I start at the origin with vector u, so -1, 3, that means my horizontal component is -1, so left 1, and my vertical component is 3, so up 3. So this would be a graph. You know what? Let me use my draw tools to try to keep things tidy if possible. Okay, so there is my vector u. Okay, now I'm going to do vector v. I need to change to my color scheme though. Okay, vector v has components 2, 4. Now, I'm not going to start from the origin, and really what I'm doing is the triangle method. Okay, maybe I'll write that here. I'm doing the triangle method. And that's where you put, you start the second vector where the first vector ended. So starting from the terminal point of vector u, now I will do vector v, which will be right 2 and up 4 because of the horizontal and vertical components. So starting from here, if I go right 2 and up 4, this would be the terminal point. So vector v, I could draw it from here to here. And I think I will use my draw tool again, okay, to draw the vector from here to here. So this is vector v. Now, the sum of these vectors will be the vector that goes from the initial point of the first vector all the way to the terminal point of the second vector, from the beginning all the way to the end of both vectors. Okay, so if I draw my vector one more time, from the beginning all the way to the end, that is going to be the sum. Now, I wonder, can I change the color real quick? Let's see, maybe I'll make it green. All right, so there you go. And so notice as I look at my vector u plus v, look at the horizontal component and the vertical component. It is over 1 and up 7, just like we got algebraically. Okay, let's go ahead and look at number 8. So vector u minus vector v. let's do it algebraically first. So we're talking about vector u, all right, which again is negative 1 comma 3. So I've got negative 1 comma 3, and that's minus vector v, which is 2 comma 4. Okay? Now, this is the same thing as having vector u. Now, I mean, I could certainly just subtract these values. Okay? But I also want to show you that subtracting two vectors is the same thing as adding the opposite. So this would be the same thing as vector u plus negative v. So it would be the same thing as vector u plus negative v. So this would be negative 2 comma negative 4. Okay? So which is the same thing as just subtracting? Either way, I'm going to get negative 3 comma negative 1. So there you go. That is u minus v. Now, by the triangle method, let's do this just like I did the last time. But focus on this. When I do my triangle method, I'm going to look at it this way. I'm going to look at vector u plus negative v, like just what I have right here. Okay, so vector u, I'll start from the origin again and go left 1 up 3. Okay, so vector u is going to look like this. I'm just going to draw it freehand this time. So there's my vector u. Vector v, well, negative v because I'm subtracting, so I'm going to do negative v. Vector negative v is left 2 down 4. So if I were to go left 2 and then down 4, that would be right here. All right? So here is vector negative v. Now this is in the way. So this is vector negative v, and this was vector u. So u plus negative v is the same thing as u minus v. So when I do my final answer, I will go from the beginning to the end, like this. Okay, so this is vector u minus v. Notice the components, negative 3, comma, negative 1, just like we got when we did it algebraically. All right. All right, so it looks like we're supposed to do the same problem using the parallelogram method. Okay, so let's do that same problem using the parallelogram method. And so for the parallelogram method, instead of writing the first vector and then drawing the second vector from the end of the first vector, this time we're going to put both vectors at the origin. So vector u was negative 1 comma 3, so that's going to go from here to here. Okay, so there's my vector u. And vector negative v, negative 2 minus 4, that's left 2 down 4. For the parallelogram method, I'm going to also put that vector at the origin. So starting from the origin, negative 2, negative 4 will put me here. So this would be vector negative v. And you know what, this might be in the way again. So I'll put vector u over there. Now for the parallelogram method, we need to draw a parallelogram. All right, I bet you did not see that coming. So I need to, these first two vectors need to form sides of my parallelogram. So I'm going to use the slope. You look at the blue. See how it goes left 3, up 1? So the other side of my parallelogram from here should go left 1, up 3 as well. So if I go left 1, up 3, all right, I'm just going to put a little dotted line here. This should be the opposite side of my parallelogram from here. Now, look at the pink side, the red side. Just looking at the slope of it, do you see how it goes up 4 and over 2? So if I pick up from here, or you know what, I guess I could do it from here, so I can follow the direction of left 2, down 4. So from here, I can see I'm going to go left 2, down 4, and of course I'm going to land at that same spot. So if I make a nice dotted line, okay, and see how they meet here. I have drawn a parallelogram. So the result of putting these two together will be from the origin to the diagonal. So if I go from here and I form a diagonal to the vertex that's across from it, then that's my answer, is this green vector. So this green vector is the vector u minus v. And notice it is the same, all right? What we got last time was a vector that was left 3, down 1. And here again, we have a vector that is left 3, down 1. Let's do that again for number 9. So if I want to do u minus w, please understand that the first thing that I'm going to do is I'm going to look at this as u plus negative w. All right, that's what I have to do. So I'm going to do negative 1 comma 3, all right, that's vector u, plus the opposite of w. So instead of 2 comma negative 5, I'm going to go ahead and put negative 2 comma positive 5. All right, that's how you would do this algebraically. So now putting these together, I'm going to get negative 3 comma 8. All right, so that is the answer algebraically. Now again, when I do this graphically, I'm still going to use this same thing. All right, I'm still going to use u plus negative v, u plus negative w in order to do this graphically. So vector u is negative 1 comma 3. So starting from the origin, that would be left 1, up 3. All right, so here is my vector u. Okay, and then now vector w, well, the vector negative w is negative 2 comma 5. So that will be left 2, up 5. For the triangle method, you pick up where you left off. So starting from here, I will go left 2, up 5. So left 2, up 5 would be right here. So this is vector negative w. Okay, so I've got vector negative w, and I've got vector u. Okay, so my final answer, what we would call the resultant vector, is going to go from the initial point all the way to the terminal point. Now this is not going to form much of a triangle. It's like almost a straight line. But we can still see the answer. So I'm going to go from the initial point to the terminal point. Okay, and there it is. I'm going to color it green again. All right, so that green is the answer, the resultant vector. All right, so I'll just write U minus W here in green. Notice the components. This vector goes left 3 and up 8, just like we predicted algebraically. All right, and look, now we're supposed to do that same thing using the parallelogram method. This problem is going to be a little bit tough to do by the parallelogram method because you can see how much of a straight line it makes. But let's do our best. So vector U again went like this. So this is what vector U looked like. And then vector negative W went negative 2 and up 5. So that was like this. Left 2, 3, 4, 5. Okay. So this is what vector... Okay, so this problem is really hard to do by the parallelogram method. But let's do our best. So if I wanted to do this by the parallelogram method, I'm going to use my slopes. So if I wanted to basically copy the blue vector, I would go to the end of the pink or red vector and I will do the same slope. So see how this vector goes left 1 up 3? So starting from here, I'm going to go left 1 up 3. Okay, so that would be one side of my parallelogram. And then doing the same thing from the end of the blue vector, doing the red vector, which is negative 2, left 2 up 5. So if I go from here, but then I go left 2 up 5, you'll notice that I land on that same spot. So, if I try to draw this, I know that does not look like a parallelogram. Technically, it is, but what matters is this point right here. So we have our answer, which goes from here to here, just like we got before. All right, not a very good example of the parallelogram method. Really, the triangle method is much better for this type of problem. Okay, now number 10, 3v. Okay, so vector v is 2, 4. So vector 3v is going to be 3 times 2, 4, which of course is going to be 6, 12. So let's just compare these two vectors. All right, the original vector v is the vector 2, 4. So that from the origin, that would be over 2 and up 4. Okay, so from the origin, that would look like this. All right, now let's look at the vector 3v. From the origin, I will go right 6 and up 12. So if I start here and if I go right 6, okay, that's 3, 4, 5, 6, and up 12. So this is 10, 11, 12 would be about here. Okay, so what I'm going to have is this. All right, notice that vector 3v is 3 times as long as the original vector v, but it goes in the exact same direction. Now let's do the same thing but without a coordinate plane. So we need to sketch vector u plus vector v. And here's vector u and vector v. We're not given the coordinates, but somehow we have to do this. Now let's use our drawing tools and duplicate vector u and vector v. So I'm just gonna draw myself a vector right over the top of vector u. Okay, so this is pretty much identical to vector u. All right, I think I will change the color though and make it blue. So this is my identical copy of vector u. Okay, now let's make a copy of vector v. All right, again, I'm going to use my draw arrow tool, and I'm going to draw a vector right over the top of vector v. So here is a copy of vector v. I think I will change the color, and I'll go ahead and let this one be pink or red. So here's a vector u and vector v. So if I want to sketch the sum of vector u and vector v, what I will do is I will put them head to tail. Okay, like this. Just put them end to end, head to tail. So the resultant vector should be the vector that goes from the initial point of the first vector to the terminal point of the second vector. So I'm just going to use my draw arrow tool one more time. So my resultant vector will go from here to here. And I think I'll make this one green like I've been doing in the rest of this lesson. Okay, so here is my sketch. This was vector u, and this was vector v. And this is vector u plus v. All right, so that's it for number 11. Okay, now I'm supposed to sketch u minus v. So when I go to do this, the first thing I'm going to do is I'm going to think of this as u plus negative v. All right, this is what I'm actually going to be sketching. All right, vector u plus negative v. So that means I can still use my copy of vector u. So I'm going to Control C, Control V, copy paste. All right, so I've got my vector u ready to go. So the only question is, how do I make vector negative v? Well, let's start with vector v. Just going to Control C, Control V. So right now, this is vector v still. Okay? Vector negative v should be a vector. Oh, I didn't know you could change the colors like that. Let me put it back. Vector negative v should be a vector that is the same length, but that is going in the opposite direction. All right, now how can I do that digitally? Rotation. If I grab this, if you go under the draw tool, find rotation. All right, you'll find where it says rotate, and I'm going to rotate it 90 degrees, and then I'm going to rotate it another 90 degrees. So now I've rotated 180 degrees. Now it is going in the opposite direction. So this is negative v. And you know what, maybe I will make this purple to indicate that this is not vector v anymore. This is vector negative v, so I made it a different color. So putting this together, so if I want to add vector u plus negative v graphically, so here's my vector u, and here's my negative v. And again, I will put them end to end. So the resultant vector will be from the beginning to the end, like this. Okay, so there you go. So I had vector u, and I had vector negative v. So that makes this the vector u minus v. All right, that's how you do it.